let us continue study of properties of the salt. So in this video, we are going to study one more property of the salt that is known as hygroscopy. That is known as hygroscopy. Now, what is this term? So here we have certain substances when they are exposed to atmosphere. So there are certain substances which we expose to atmosphere at ordinary temperature shows a tendency to absorb moisture from the air, but they do not dissolve in it. Unlike your unlike your deliquescent substances, these substances do not dissolve in it. So here, without dissolving in it, that is called as hygroscopy. So once again I repeat, it's a property where certain substances shows a tendency to absorb moisture from the surrounding air but does not dissolve in it. That is known as hygroscopy. And the substance which exhibits this particular property, those are called as hygroscopic substances. The example for that particular is a typical we come across, that is silica gel. Now you must be observing this silica gel either in capsule bottles or new water bottles if you purchase. In this you must be seeing this silica gel. So it's a generally shows a tendency to absorb moisture. See, whenever we open the capsule bottles and close it, now capsule is made up of substance that's called as a plasticizer. And suppose if your wet hand touches to the capsule, it becomes sticky. So to keep the environment inside that bottle dry, we are putting this silica gel in that. So there's one small cushion kind arrangement is been kept, in which we are having a small packet is there. On that it's written silica gel, do not swallow it. So it generally keeps the environment in that water bottle free from moisture. So it doesn't affect the capsule. Okay, so that's a typical silica gel as an example. Now let us see few more examples related to hygroscopic substances. So here we have the examples like anhydrous CaCl2, concentrated sulfuric acid. It's also typical drying agent, we can say, or hygroscopic substance. Phosphorus pentoxide is there. Calcium oxide, which is also known by another name, quicklime. Silica gel, I shown the example above in a picture. And alcohol may be typical in terms of ethanol. These are the few examples where they show a hygroscopy as in property. Now, hygroscopic substances are generally anhydrous solid or liquid. Hygroscopic substances are generally anhydrous solid or liquid. See here, if you can see anhydrous calcium chloride, that is solid. Concentrated sulfuric acid, that's liquid. P2O5, that's solid. Calcium oxide, solid. Silica gel, that is solid. Ethanol, that is liquid. So here, these are the certain substances which shows property as in hygroscopy. Now generally these hygroscopic substances are also used as drying agent because they show a tendency to absorb moisture from gases. That's the reason these substances are used as drying agent. Let us take an example. We have hydrogen chloride and carbon dioxide gas. So we have hydrogen chloride and carbon dioxide gas. Now these two gases are generally acidic. Okay, so I use concentrated sulfuric acid, which is also an acid. So we do not have any reaction taking place between them. So hydrogen chloride gas, which is acidic in nature, carbon dioxide gas, which is acidic in nature, can be dried using concentrated sulfuric acid, which itself is an acid. Now, ammonia. Now, ammonia is a basic gas. So I cannot use acid over there. I cannot use concentrated H2SO4 to dry ammonia gas because it will react. So in order to overcome this difficulty, we are using quicklime or calcium oxide, which is generally basic in nature, So I do not have reaction between ammonia gas, which is basic, and calcium oxide, which is also basic in nature. Okay, so base won't react there. Now, in previous video, we have discussed about deliquescent substances. So we have discussed about deliquescence as a property. So what's the basic difference lies between a deliquescence and hygroscopy? See, primarily both of them absorb moisture. Both of them absorb moisture at room temperature or at ordinary temperature, but hygroscopic substances do not dissolve, whereas deliquescent substances dissolve in the moisture absorbed to form saturated solution. That's the difference. Hygroscopic substances do not dissolve in a moisture absorbed, whereas deliquescent substances absorb moisture and dissolve in it to form saturated solution. Then, hygroscopic substances do not change its physical state on exposure. That means solid, if it's there, it will remain solid. Liquid is there, it will remain liquid. But deliquescent substances generally shows a tendency to undergo change of physical state. See, for example, if we have solid sodium hydroxide, you take it. If you keep it in open, after some time, maybe half hour or so, we'll be able to see a saturated solution. That means solid sodium hydroxide turns into a liquid. So there is a change in physical state is seen. Then hygroscopic substances may be your amorphous solid. Means they do not have definite geometrical shape, whereas deliquescent substances are by default crystalline solid. Because most of them are hydrated salt. Most of the deliquescent substance, if you see the examples of that, they are basically hydrated salt. Thank you for watching.